Assalamu alaikum wa rahmatullahi wa barakatuh. It's me, Omar, and my colleague Ahmed from the SE department, System Engineering Control line. And we are working in our senior project under the supervision of Dr. Anas Waqar. So our project mainly is a tele-operated arm. But is it just a tele-operated? Because the concept of controlling a robotic arm from a distance is there from a long time. What is so special about our project? Why is it so important? I will go through the details of our project and how is it special, but before that, let me introduce the problem that we are trying to solve. So what is the problem? In many situations, a human intervention is needed. The human has to intervene in something, fixing a problem or something. However, it's very dangerous to exist physically at that location. Either because because you are fixing an equipment in a plant that is about to collapse in any moment, or for example, if you are entering an area with poisoned liquid, gas or so, or you are fixing a sparky equipment with an area that is flammable, or you are trying to defuse a bomb. So in all these are examples of situations where the human has to interact with the system, but it's also dangerous to exist physically there or to come in contact. So how do we approach the solution, or how do we solve this problem? Well, so let's take the defusing a bomb as an example and go through it. So we have this guy, this bomb specialist, trying to defuse a bomb. The problem is that they are in contact, so anything goes bad or goes wrong means he will lose his life. So the first solution that came to mind is to separate the guy from the bomb. So now they are in two different locations now. Then what do we need? We need something to control the bomb from distance. So we need an arm probably and a joystick. Well, this is one proposed solution, and it's probably a good solution, but the problem with this solution is that if you give this joystick to this bomb specialist and tell him to defuse the bomb, he wouldn't be a specialist anymore actually, because he would require a lot of training on this joystick and before he's able to use it. So he will not be able to use his previous experience, because it's a new device to him. So we decided to replace this joystick with a new sophisticated sensor called the leap motion controller. Now, what is so special about this leap motion sensor is as you wave your hand over the sensor, it captures the position and velocities of your hand as well as your fingers. So now we can use this data and send it directly to the arm to control the position of the arm and the movement of the arm. In this case, the arm is following the hand of the specialist. So he is not required to use any new device or learn anything new. He will just wave his hand and the arm will follow his movement. But we still need to provide the vision for the specialist because he is in a different room. So we provided a camera at the stage of the arm and the feedback, the visual feedback is provided through Oculus Rift goggles worn by the specialist. And to complete the setup, we have the sensor transmitting data wirelessly to the controller, and the controller controls the arm. By this, the setup of our project is complete. Now, this was the example of the bomb, but it works for any other example where either you are fixing an equipment or even it has applications in medical area also. The concept known as doctoring at the distance. So the doctor is able to treat his patient from a distance using the concept of this arm. So surely it has a good effect on society, whether it's in medical application or fighting, national security, fighting terrorist activities or whatever, using bomb, for example. Now, one main concern in our project is how smoothly the arm moves. Now, this is a big concern because the last thing, for example, a bomb specialist want to see while defusing a bomb is the arm jumping to somewhere else and cutting the wrong wire. Now, this would definitely get him fired. I mean, I mean literally fire. This will be a big problem. So what about smoothness? We examined such jerky motions with the arm in the early stages of the project, but we were able to get over that by playing with the communication side, because communication affects smoothness directly. So we found out that if we allow some delay between the position commands that are going to the arm, if we allow some delay between the commands, we can get better smoothness, and the arm moves smoothly without jerky jumps. So then comes the question: what if I can buy this from outside somewhere else? Because there could be some projects or prototypes that use the same concept of leap motion sensor and stuff. Well, the main idea of this project is to make this or such a technology available locally and affordable costs. This is how we see the problem. This is my presentation, and thank you all for listening. If you have any questions, you're most welcome. Thank you so much.
Thank you. Now it's your turn to